Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 6, for broadcast on the 13th of January 2023. Coming up on SpaceTime, a massive blast on the volcanic moon Io, how the Sun's activity influences deep space cosmic rays, and Europe's newest advanced weather satellite launched into orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected a massive eruption on the volcanic Jovian moon Io. The outburst was discovered by the Planetary Science Institute's IO Input-Output Observatory near Benson, Arizona. The massive plume began building up in July and continued until December. The facility's been monitoring volcanic activity on Io since 2017. Volcanic eruptions aren't unusual on Io, in fact they're commonplace. And the IO Input-Output Observatory's observations have shown some sort of major outburst nearly every year. But the late 2022 event was the biggest by far. Io is the innermost of Jupiter's 4 large Galilean moons. The others are Europa, Ganymede and Callisto. What makes Io special is that it's the most volcanic world in our solar system, thanks to the gravitational tidal stresses it feels as it's constantly squeezed and stretched by Jupiter and 2 of its large siblings, Europa and Ganymede. The IO Input-Output Observatory uses a chronographic technique which dims the light coming from Jupiter to enable imaging of the faint gases near the planet. The brightening of 2 of these gases, sodium and ionized sulfur, began between July and September 2022 and lasted through until December. The ionized sulfur forms a donut-like structure that encircles Jupiter, known as an ion plasma torus. But curiously, it wasn't anywhere near as bright during this latest outburst as had previously been seen. One of the study's authors, Jeff Morgenthaler from the Planetary Science Institute, says it could be saying something about the composition of the volcanic activity that produced the eruption. Or it could be that the torus was more efficient at ridding itself of material when more material was thrown into it. The observations have profound implications for NASA's Juno mission, which has been orbiting Jupiter since 2016. Juno flew past Europa during the start of the outburst, and is now gradually approaching Io for a close encounter in December. Several of Juno's instruments are sensitive to changes in the plasma environment around Jupiter and Io, and that can be traced directly to the type of volcanic activity being observed by the IO Input-Output Observatory. Morgenthaler says Juno's measurements should be able to tell whether this volcanic outburst had a different composition to previous events. In addition to observing the Jovian Sodium Nebula, the IO Input-Output Observatory also observes Mercury's sodium tail, as well as bright comets and even transiting exoplanets. This is SpaceTime. Still to come, how the Sun's activity influences deep space cosmic rays, and Europe's newest advanced weather satellite launches into space. All that and more still to come on SpaceTime. Astronomers have discovered how changes in the Sun's 11-year solar cycle affect the ability of high-energy cosmic rays to reach the inner solar system. The measurements taken by the European Space Agency's Mars and Venus Express missions were able to capture the dance between the high-energy cosmic rays and the influence of the Sun's activity across the inner planets. High-energy cosmic rays are subatomic particles travelling at almost the speed of light, which originate from outside our solar system. They're thought to be caused by things like supernova explosions and black holes. and they're a dangerous form of high-energy radiation capable of causing electronic failures in spacecraft and damage to DNA in people. The new findings, reported in the Astrophysical Journal, show that data from the Aspera plasma sensor, an instrument carried by both the Mars Express and Venus Express spacecraft, when compared with sunspots visible on the surface of the Sun, show that cosmic ray counts are being suppressed during peaks of activity in the 11-year solar cycle. As well as the decade-long relationship with the solar cycle, the authors also looked at how cosmic ray detections would vary over the shorter time scale of a single planetary orbit. Surprisingly, they found the area protected from cosmic rays behind the planet Mars was almost 100 kilometers wider than the planet's actual radius. The cause of why this blocked area should be so large isn't yet clear. The study's lead author, Yoshifumi Futana from the Swedish Institute of Space Physics, says the study shows a range of valuable insights can be derived from what's actually nothing more than background count information collected by the Aspera instruments. Futana says understanding the various relationships between cosmic rays and the solar cycle, the atmospheres of the planets, and the performance of spacecraft instrumentation will be important for both future robotic missions as well as human exploration. Launched back in 2003, Mars Express remains in service around the Red Planet, while Venus Express operated from 2006 to 2014. Futana and colleagues compared the 17-year data set from Mars Express, the 8-year data set from Venus Express, as well as Earthbound cosmic ray measurements from the Thule neutron monitor in Greenland. The authors took median value cosmic ray counts over 3-month periods in order to minimize the influence of sporadic solar activity such as cosmic rays and coronal mass ejections. The database of cosmic ray radiation counts showed a distinct decrease in the number of cosmic ray detections at the peak of activity for solar cycle 24. The Mars Express data and the observations from Thule on Earth showed very similar features. However, there was an apparent lag of around 9 months between the maximum number of sunspots and the maximum cosmic ray detections at Mars. That matches up with previous studies, which had already suggested that there may be a delay of several months between solar activity and the behavior of cosmic rays at Earth and Mars. Futana says these new results appear to confirm this, and they also provide evidence that solar cycle 24 was a bit unusual, perhaps due to the long solar minimum between cycles 23 and 24, or the relatively low activity during cycle 24. The analysis of the Venus Express data was more complicated because of changes in the way onboard processing was carried out after 2010. Also, while the Aspera instruments carried on both Mars and Venus Express missions were based on a common design, they were each tailored for the very different planetary environments in which they operated. This means that a direct comparison of cosmic ray fluxes at Mars and Venus wasn't possible using the available database. The idea of using background counts to study the interaction between cosmic rays and high-energy particles with planetary missions is relatively new. But Futana says obtaining this information shows potential as a powerful new tool for the upcoming Jupiter Icy Moon Explorer or JUICE mission, which will study the harsh environment around Jupiter's icy moons.
My scientific philosophy is that I would like to answer a question that people never even thought about it. This paper is really aligned to my philosophy that people never take noise data seriously, but we did it and successfully extracted information about valuable science.
The fascinating part of this study is we used noise data from our instrument on Mars and Venus that were built at the Swedish Institute of Space Physics here in Kiruna. Noise data was considered as garbage or junk, so that no one has seriously looked at this data. And we developed an algorithm to extract galactic cosmic ray information from noise data. And we have successfully done it.
Galactic cosmic ray is an important cause. It can cause instrument errors in the space system, as well as it destroys the DNAs of human bodies. It's a threat for the future exploration in space. So all the human activity in space.
That's Yoshifumi Futana from the Swedish Institute of Space Physics. And this is SpaceTime. Still to come, Europe's newest advanced weather satellite takes to the skies, and later in the science report, a new study shows that Australians aren't very good at guessing how much alcohol they've had to drink during a big night out. All that and more coming up on SpaceTime. The European Space Agency has successfully launched its first Meteosat Third Generation Imager satellite, the MTGI-1, into geostationary orbit. The spacecraft was flown aboard an Ariane 5 rocket from ESA's Kourou spaceport in French Guiana.
6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des EAP, décollage. La propulsion est nominale.
And we are off. How wonderful to see the mighty Ariane roaring across that equatorial sky. Definitely a launch to savor. We are now over 1 minute into the flight as she powers her way into space, heading east out over the Atlantic Ocean.
It's hard to get tired of it, right? I mean,
it's amazing.
Look at this.
Yeah. I might be an engineer, but still I have emotions when I see that. No, that's amazing.
Like a ball of fire thrusting itself.
No, and we are extremely lucky because we can clearly see the rocket like blasting its way towards
Raphael,
space.
what do you have to tell us?
Well, I mean, everything is going to happen quite quickly now. You'll have in a few seconds the booster separations.
That's the first thing we have to look out for.
Yeah, they will have provided 90% of the overall thrust in order to literally escape the gravity pull of the Earth. And then you will have the separation of the fairing when we have crossed the limits of the atmosphere. It's protected the satellite from the friction of the air, but also from the noise generated at the booster's ignition. And then we will have the separation of the main cryogenic stage. And here you can see the booster separation. Yes. So it's confirmed by the DDO.
So, Mathieu, without these two boosters, the launcher is obviously now a lot lighter. So than it was at takeoff. Its load has been lightened by how many tons, and why is this necessary, even essential? Does lighter mean faster?
Yeah, it was 775 tons on the launch pad. Now it's about 156 tons because we got rid of these empty boosters. Imagine that we managed to get rid of about 500 tons of propellant in about 2 minutes and 20 seconds. But this is the amount of energy that you need to go to space.
From its perch, some 36,000 kilometres above the equator, this new all-weather satellite will provide state-of-the-art observations of Earth's atmosphere, as well as real-time monitoring of lightning events, providing crucial observations for the early detection and prediction of fast-moving severe storms, weather forecasting and climate monitoring. Built by Thales Space, the satellite carries two completely new instruments, Europe's first lightning imager and a flexible combined imager. The lightning imager will capture individual lightning events in all weather conditions, day and night. It's the first time a geostationary weather satellite will have the capability of detecting lightning across Europe and Africa, as well as the surrounding waters. MTGI-1 will continuously monitor more than 80% of the Earth's surface, looking for lightning discharges taking place either between clouds or between clouds and the ground or sea. The flexible combined imager uses two scanning services to build up a picture of fast-moving storm events, scanning the entire hemisphere every 2.5 to 10 minutes across 16 different spectral bands. The data acquired will provide information about everything from clouds to water vapor to oceans, even to local wildfire events. These images will enable earlier prediction of severe weather events and improvements to forecasts. The new spacecraft will also carry two smaller payloads, designed for data collection from remote science beacons and for search and rescue operations by detecting emergency beacons. MTGI-1 is the first of 6 satellites that will eventually provide the full MTG constellation, providing weather forecasting data over the next 20 years. In full operation, the mission will comprise 2 MTG-I satellites and 1 MTG-S or sounding satellite, working in tandem. As well as the Meteosat Third Generation Imager satellite, the flight also carried Intelsat's Galaxy 35 and Galaxy 36 telecommunications satellites. This is SpaceTime. And time now to take another look at some of the other stories making news in science this week with the Science Report. A new study examining the history of sea level rise and glaciation during the last ice age has shown that the Bering Strait land bridge connecting Asia to North America didn't actually emerge above sea level till around 35,700 years ago. That's less than 10,000 years before the height of the last ice age, known as the last glacial maximum. The findings, reported in the Proceedings of the National Academy of Sciences, indicate that the growth in the ice sheets and the corresponding drop in sea levels occurred surprisingly quickly and much later in the glacial cycle than previous studies had suggested. It means that more than half of the glacial ice volume of the last glacial maximum grew after 46,000 years. During the last glacial maximum, which lasted from 26,500 to 19,000 years ago, ice sheets covered large areas of North America. This dramatically lowered sea levels and uncovered a vast area of land now called Beringer that extended from Siberia across to Alaska and supported herds of horses, mammoths, and other Pleistocene fauna. But as the ice sheets melted, sea levels rose and the Bering Strait became flooded again, around 13,000 to 11,000 years ago. The new findings are interesting in relation to human migration because they shorten the time between the opening of the land bridge and the arrival of humans in the Americas. The timing of human migration to North America remains unresolved, but some studies suggest people may have lived in Beringer throughout the height of the last ice age. Scientists are warning that Antarctic wildlife are facing multiple threats to their existence. A report in the journal PLOS Biology warns that under worst-case scenario modelling, nearly all of Antarctica's land-based animals will decline by the turn of the century under existing conservation efforts, with the emperor penguin most at risk. Researchers are urgently calling for a series of 10 updated threat management strategies. They say that while influencing global policy to limit climate change is the most beneficial strategy, minimising the impact from human activities and improving planning and management of new infrastructure projects are also cost-effective ways to minimise threats to Antarctic biodiversity. Well, a new study has shown that Australians aren't very good at guessing their blood alcohol content during a night out. Findings reported in the journal Drug and Alcohol Review are based on surveys of some 2,000 people enjoying a night out and asking each to estimate their breath alcohol content before testing them with a breathalyzer. Researchers say those with a low breath alcohol content were likely to overestimate their levels, while those with higher breath alcohol content were far more likely to underestimate. And mildly intoxicated participants were most likely to accurately guess their level. The authors say participants with a high breath alcohol content who underestimated it were also more likely to report having recently been kicked out of a venue. Psychologists and cognitive scientists have dismissed claims that your adult personality is based on a small handful of core memories from your childhood. The move follows a new TikTok fad in which users are making so-called core memory posts about salient memories from their childhood. The problem with this narrative is that you don't have just a few core memories. They don't drive personality. Childhood memories aren't always the strongest. In fact, you can't predict what will or won't become a core memory. And most importantly, core memories, or any memory for that matter, is not an accurate snapshot of a past event, but they're prone to change each time they're recalled, resulting in errors sneaking in or key events being forgotten. Tim Mendham from Australian Skeptics says, the latest scientific research suggests that while you use your memories to construct a sense of self, and these core memories do support psychological well-being, the notion of a core memory in the TikTok sense is faulty.
There's a theory going around that you have a small number of core memories which influence your personality. Okay, this has been promoted in a lot of places. Pop psychology, basically. You could almost say it's a bit of a Freudian idea that you have, say, 4 or 5 core memories, whether it's warm memories or scary memories or what, from your childhood, and that these decide where you will end up being from a psychological personality behaviour point of view. But there's problems with it. For a start, we have more than 5 memories. You probably can call up hundreds of memories. You might have, important ones might be dozens and dozens and dozens of really strong memories that you remember, good or bad. Sometimes they're mundane memories, but not necessarily traumatic, but you have a lot more memories than 5, so that one's out of the way. Core memories don't drive our personality. Our personalities tend to be, your real personality that impacts your behaviour tends to be more adolescent, right, than early childhood. But perhaps early childhood memories are nicer. And that's certainly something that you get in Freudian psychology, where the early years of trauma affects your personality and your attitude towards things. Childhood memories are not necessarily always our strongest ones. Adolescent memories, again, might be stronger because it's a period of change and sometimes stress for a lot of people. So, if you're going to have core memories from anywhere, it's probably going to be from your teenage years. You obviously can't predict what will become a core memory. It might be, as we say, sort of just something really mundane, but it was nice. Someone patted you on the head and you thought, oh, that's a really nice moment, whatever. And memories, as we all know, are not necessarily accurate. And over the years, you can sort of change them. You can fabricate situations in memories. You can say the Mandela effect.
The Mandela effect is people remember what they were doing when Mandela was shot.
That's right. So a bit of a mixing up things. Nelson Mandela wasn't shot. To start. So they're mixing up a bit of John F. Kennedy assassination with a Nelson Mandela thing and throwing it in. And this memory becomes so strong that people say, oh, definitely, I remember I was standing in the middle of a shopping centre and I heard the news that Nelson Mandela had been shot. He pointed out he never was shot. Oh, memories are very unreliable. The longer the memory is ago, the more distance between when you're talking about a memory, the less reliable it is. If there are particular reasons why you change a memory to say, I was there, I wasn't there, this was different, that was a situation, a court will tell you that an old memory is very dodgy, and people can manipulate your memories for you. They can influence you. They can make suggestibility issues, or you can change it yourself. Anyone who's talking about particular memories, you have to be very, very careful because they're often not correct. People who said, I was there when they weren't and couldn't be, and they were convinced they were there because they manipulated their memory. They wore a red dress when it was a blue dress. There were 17 people there when there was 2. I was at Woodstock. So
those who really were there can't remember it anyway.
That's right, yes. So, there's all those issues. But core memories, a lot of myths about it. More than memories than just 5. They don't drive your personality. There's probably the childhood memories are not as strong as the adolescent ones. You can't predict what's going to be a core memory either, obviously, and memories themselves are not very accurate.
That's Tim Indham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.